All right, in this video, we're going to talk about the root test, very similar to the ratio test. You'll notice there's a condition here. We have an infinite series with non-negative terms, and r is equal to the limit of the nth root of a sub n. All right, so that's the nth root of a sub n. Now, there's a limit again, though, and the three results are going to be the same thing. If that r is less than 1, then the series converges. If r is greater than 1, or the limit as n goes to infinity of the nth root of a sub n diverges, the series diverges. And then finally, if r is equal to 1, this test fails, and we need to find another test to use. So you'll notice here, look at what's here. We have a power of n. So that's a perfect use of the limit as n goes to infinity of the nth root of n plus 1 over 2n minus 1 to the nth. Since these are all positive or non-negative, the nth root would just balance out with the power of n. We would just get n plus 1 over 2n minus 1, which is just 1/2, which is less than 1. So therefore, the sum n goes from 1 to infinity. N plus 1 over 2n minus 1 to the n converges by the root test. So the key here, what made this one so easy, was that the a sub n term was a power of n. So that's what you're looking for here to use the root test, is when there is a power of n. Ooh. All right, I think I remember how to do this one. Ha! I don't have my notes with me. I'm at home, so we'll see if I can remember. Let's see. We've got powers of n. This one's weird. It's kind of inside n factorial to the nth over n to the nth squared. Let me rewrite that, because I'd like to get just a power of n. So that could be n to the 2n. Then we could write it n squared to the nth. Right, we could kind of switch those. That's multiplying. Again, you're still going to get 2n. So let's do the limit as n goes to infinity of the nth root of a sub n. That's the limit as n goes to infinity, the nth root of n factorial to the nth over n squared to the nth. So that's the limit as n goes to infinity of n factorial over n squared. And if we look at this one here, this should be fairly obvious. The numerator is an nth degree, right? N times n minus 1 times n minus 2 times etc. 3 times 2 times 1. The denominator is just n squared. And so that is definitely infinity. That diverges. And so therefore, our series n goes from 1 to infinity, n factorial to the nth over n to the nth squared. I think you probably could have just done the nth term test for divergence there on that one too. But that one diverges by the root test. All right, and let's try this last one. We've got, so e to the 2n over n to the n is really e squared to the nth over n to the nth. So that's really, I guess we could combine these, e squared over n to the nth. Notice this is not geometric, because the common ratio here, it is not a common ratio. It changes. It depends on n. So this is not geometric. Now, of course, we're practicing the root test, but on the exam, you're not going to be told. You're not going to be told which test to use. So this one might be tempting to think is geometric, but it is not. So the limit as n goes to infinity of the nth root of a sub n will be the limit as n goes to infinity of the nth root of e squared over n to the nth, which will be the limit as n goes to infinity of e squared over n, which is 0, which is nice. That's less than 1. And so therefore, this series, n goes from 1 to infinity, e to the 2n over n to the nth converges by the root test. And I just realized I probably should have done one where this test failed as well and we had to try something else. I don't think that happened here, right? We had one, first one converged, the second one diverged, and then this one converged. But, you know, just keep your eyes out for that. If you get one here, then you have to try something else. So that is it. A couple of quick videos there. We would have taken more time in class and had you try some of these on your own. But we'll pick up from here, summarizing the convergence tests. You know what? I think I might make another video actually about that one because I have the solutions actually to all those. Yeah, so we'll make one more video for the convergence tests, and then we'll pick up from there in the next class.